Hi, I'm Laurin. I'm from the Guild, and this is Kamil, also from the Guild, and today we're gonna host the GraphQL Hive workshop here. And I'll be mostly leading the workshop, and if I'm saying something wrong, Kamil will probably shout at me and correct me. So this is roughly the workshop agenda today. So first we're gonna do a small intro about why evolving GraphQL can be hard. Then we talk about schema registries, breaking change detection, usage reporting, conditional breaking changes, and last we'll also have like a QA round. All the workshop material is like available in this GitHub repository. You can download it, but because like of Wi-Fi constraints and also time constraints, it's probably best if like I do most of the things and you don't like have to precisely follow along, but you can like still look at the code if you want to look at it. And then afterwards, after like the workshop or in the evening, I recommend you to like take a deeper look at the material and try some things yourself if you're interested in that. So without further ado, evolving GraphQL can be hard, right? I mean, it can also be easy in a simple setup. Let's imagine that we have like one repository where we have like one GraphQL schema, like one GraphQL server, and we have like one GraphQL client. This is basically a very simple setup, and there rolling out changes is quite simple. Because like when we edit the GraphQL server, we can also at the same time also update our GraphQL client. And thus we can like mostly prevent breaking changes from happening, because we can also deploy both the client and the server at the same time. If we're talking about Git or like GitHub, this is like often done in a single pull request. We update our GraphQL schema, then we update our GraphQL operations, and then we deploy to production. And then usually nothing will break, hopefully. But there's also like more complex setups. So at some point, we don't have like one client. We might have different clients, and they might not be in the same Git repository as our GraphQL server. They could be like in a different repository owned by a different team within our organization, or they could even be like external from a completely different company. So in a complex setup, we have many different teams, products, and developers. The GraphQL API and clients are owned by different teams, and also the code could be spread across many repositories or even companies. And inevitable breaking changes will happen. So I actually want to like ask the audience, like, who is here is already using GraphQL? Can you shortly raise your hand? Okay, cool. And who of those using GraphQL already had like a breaking change deployed to production that broke something? Okay. So one that I often saw like in applications that not only need to use GraphQL is something like this. Laurin lives in undefined. So what happened here? Maybe we have like a template that takes a user object and uses the name and then the hometown property to like form a sentence that is then displayed on our website. And how could that happen? Well, if we look at a traditional REST API, you have like an endpoint that represents a resource. And then maybe at some point someone edited this REST endpoint and thought, hey, this one property, we don't need it anymore. And they removed it. But not all code that was actually using this property was considered. So we actually removed like a property that is used in production. And this is how we get these kind of things out in the wild. So with GraphQL, it's actually quite similar, but instead of like having one endpoint, we actually have one endpoint, but not per resource. We have like one GraphQL schema that defines the resources that are available. And then on the other hand, we also have like GraphQL operations that define what kind of data we want from the server. And basically we can use this information for our benefit. So I have some examples here of like breaking changes and schema changes, and I want to make a small quiz. So who thinks that adding this field would be a breaking change in the GraphQL schema? Okay, And who thinks that it is not a breaking change? Okay. Okay, next one. So here we have a field that is nullable and we make it non-nullable. Is this a breaking change? Yes? I don't think so. Oh, actually, yes. Yeah, this is a breaking change because like some clients might use the hometown field and expect it to be non-nullable, but now the server sends us null back and then the client breaks. And then we have another example. We have a field that is non-nullable and it's, yeah, we have a field that was non-nullable and it's made nullable. Actually, this was not a breaking change. You messed with me. So a field that is nullable, that becomes non-nullable, is not a breaking change because the client can accept, knows that the property might exist. So if it's in the future no longer nullable, it's still a fine. On the other hand, this is the issue. Like the client expects the field to be there, but now it might be nullable. So this is actually the issue. And then we also have like this example. So we're changing the color of the field. Yes, this is also a breaking change, just to not keep this confusing. So as you can see, it's like hard to define or like spot what is actually a breaking change, even for me. So how can we basically reduce human error with schema changes and kind of like automate this process of spotting these breaking changes and informing us before we actually break something? So this is no longer happening, but instead we can deploy and be like this. As I said, schema changes are dangerous and can break lines. So if we look on how we deploy, so this is probably like the easiest deployment flow. So we develop, then we have our CI system that basically checks if our code is working or not. And if it's not working, we develop more until it's working. And then when it's working eventually, we deploy the code to production, right? So one tool that we developed a long time ago is called GraphQL Inspector. And basically what you do is hook it into your CI system. And what it does is basically validate the schema. And it can also detect breaking changes by comparing the last schema version with the new schema version. And then it can also report that on as a status on the GitHub action. So instead of us having to guess about these examples to be like breaking changes or not, we can actually like use a tool that has those rules already baked in for doing this, running these checks. So I'm gonna actually like show you this now. So here, can everyone read this, by the way? Is it big enough? Okay, cool. So let's clear this. So I prepared here the exactly same schemas. So here we have a hometown property. Here we don't have a hometown property. And now I can actually use the GraphQL Inspector command. So we have the before, and then we will also add the after one. And if I run this, it will actually tell us whether it's a breaking change or not. And here we say, see, detected the following changes between schemas. So a new field was added on the object type user, and the tool did not categorize this as a breaking change. So for us, it would be fine to simply deploy this without having to like be concerned about anything. So let's also run this for the other examples. So here before, and also here after. So you can see, oh, this is a breaking change because we switch from a non-nullable field to a nullable field. And then also, if we now reverse these, so if we now run it the other way around, it's actually no longer a breaking change, because like changing a nullable field to a non-nullable field is quite fine. So this approach works pretty well when you have like a single GraphQL service that is like in a repository, and you can easily like get the previous commit schema version and the next commit schema version and then diff those. But that's not how all the GraphQL setups look like, because we also have like federated or composite schemas, and this is more like a complex setup. So here we have multiple GraphQL APIs that must not be in the same repository. It could be anywhere, like in different GraphQL Git repositories, or like different companies owned by different teams, and they together are aggregated into a single supergraph that then is used for like the outside world. And here we cannot simply use this tool. We could probably in some way, but it's like way more complicated to set up like this CI flow for like many Git repositories. And in addition, the GraphQL inspector tool only gives us like the changes for the moment, but maybe on the long term we want an overview over all our changes over time. We want to like see how our GraphQL schema evolved. Yeah, so their GraphQL inspector might not be like the best pick. And this is where the schema registry actually comes in. So a schema registry is basically a centralized repository for managing and validating GraphQL schemas. So that means instead of like having a single source of the schema within our Git repository, we will instead push all our GraphQL schemas of our single subgraphs from our Git repositories to this registry, and it will be then the source of truth, because it will first of all validate the GraphQL schemas that we send to it, and then it would also make sure that the GraphQL schemas that we send to it, if it's multiple schemas, can be like aggregated into a single schema. And then on top of that, we also get like a full schema history, basically version control for GraphQL. And also, as with GraphQL Inspector, we get like a categorization of the schema changes. We know whether they are breaking, safe, or maybe conditional breaking. I will talk about conditional breaking later on, more in detail. So how would such a workflow actually look like? So instead of like using GraphQL Inspector, which is like a CLI tool, we still have our Git flow, obviously. So what we would do in CI is use a schema registry, in this case GraphQL Hive, which is an open source GraphQL schema registry that we are developing. You would use in your CI process, you would use the schema registry to make sure that the changes that you're doing in your code are still valid with the schema, so you don't break the schema. And then what we also want to know during development is whether our supergraph is still composable if we use a federated schema. And then also, like with GraphQL Inspector, we want to detect the breaking changes and also report the status back to our Git repository, so that the developers automatically can see what kind of impact their changes on the GraphQL subgraph or schema that they are working on has on the supergraph. And then after we developed our schema change and iterated on that, we will probably also want to deploy this to production again. And there, the benefits of the schema registry is first that we have all the changes persisted, so we can see like who changed what fields and what fields were added during which deployment, which fields were removed during which deployment. And then also, if we are using a federated schema, we need some kind of artifact that we give to our GraphQL router so it knows which request needs to be routed to which subgraph. And this is also like served via the schema registry. Yes. So with GraphQL Hive, this is done with 2 comments. So you also have a CLI for Hive, similar to GraphQL Inspector, but instead of like running locally, the Hive CLI will actually like connect to the schema registry and then also run logic there. So all these steps that I just mentioned will actually be executed on the schema registry and not within the GitHub action. I mean, the GitHub action will trigger the check runs. Yeah, so I think this is a great, good moment for like showing you GraphQL Hive. So as I said before, GraphQL Hive is fully open source, so you can easily self-host it, and the easiest setup is just to download the Docker Compose file from the repository and then run Docker Compose up. So we're gonna do this, and hopefully it will work. So there's quite a few containers involved because it's like a full platform, but we can maybe get a bit into detail what is actually running later in the Q&A if there's like interest. But for now, you just need to know that this is like a platform that you can use to publish your GraphQL schemas. So we're running this on localhost. Oops, it's not good. Okay, just gonna sign up. Yeah, so the first time you sign up, oh, should probably make this a bit bigger. Is this readable for everyone? Yeah. No complaints, okay, cool. So the first time you log into GraphQL Hive, you will be asked to like create an organization. I'm gonna call this GraphQL Hive Workshop. Yeah, so, and then we go to the, we are redirected to the organization page. So if you look at the members of our organization, it's currently only me, but we can also like invite other users, and if we want, we can also like add an OpenID connection provider of like Okta or Auth0 to like automatically sign up users when they first log in. And yeah, so the first step here would be to create a new project. So we're gonna first like create a single GraphQL schema project. We're gonna go into Federation later on, a bit more detailed. So I would just workshop 1, and let's create this. And then we have our project. So in the project we have like targets, and the targets basically specify one of the 3 like stages. These are the default stages. Like if you have custom stages within your company, you can obviously also create new targets and rename them according to what you need. And for this demo, we're going to use the development target. So when we open that, we are automatically on the schema tab. And now what Hive is telling us is that we're waiting for the first schema. So let's push the first schema to GraphQL Hive. So it's going to open a new terminal. And I also prepared some simple schemas here already. So this is the first schema that we want to push to Hive. Actually, in order to push the schema to Hive, we need to create an access token so we can push it. So we're gonna create a new registry access token. We add a description, just R for now. And then just give full access. Generate it. Come on. Come in. Okay, we're gonna copy this token, and then because I was afraid that the internet might not be as good, I already installed some dependencies. So I already installed the Hive CLI, and if you later on use this repository, you'd only need to install the dependencies and everything is ready to use. So I already set up the endpoint to the GraphQL registry, which is like running on my machine right now, and I'm gonna replace the access token. And oops. So now I should be able to publish my first schema. I will do that, and it's simple schemas. One, special schema. Oops. Hey, it worked. So we also get the link here. So let's click on that. We can see, wow, we deployed our first GraphQL schema. And now if we go on the history tab, we can actually see, oh, this is the first composable version that was published. So obviously this is not the, we will publish more schemas, right? So let's also publish the second schema. And here we can see that we are adding just another field to the existing schema, right? So let's also do that. And then when we reload here, we can now see, oh, we have some schema changes. Those are saved changes. So a new field was added to our query root type. And here we can also see, well, a full div, this field was added. And also when we now go to the schema tab, we can see the full schema here as well. So this is basically the Hive check part that we're doing on, would we be doing on our, no, this is the Hive publish part that we would be doing after we are sure that our schema works. So we push it to the GraphQL schema registry. But actually, before we publish the schema, we should actually check whether it's safe to publish it to the schema registry. Because if we publish a breaking change, clients might break, right? So the second comment that you have is actually the Hive check comment. So instead of schema publish, we can say schema check. And this time we're gonna use a schema that will definitely break the registry, because here we are changing the field type of the meaning of life. That's actually a typo in there. We change it from integer to string. So this time we're not gonna publish, we're gonna check. It's 0.2. So it's check, we run the check command, and now it says detected one error. Field query the meaning of life change type from int to string. And it's here again for your convenience. And we can also see this now on the checks tab within GraphQL Hive. And here you can see who run this check. So when we later hook that up to a Git repository, it's actually linked to GitHub. And here we see the breaking changes. We can again also see the div, and we can also see the schema if the composition succeeds, which is the case here. So what we can now do, if we are like, okay, it's fine with this breaking change, we can approve it. But in this example, it doesn't make any sense because it's not hooked up to a GitHub repository yet. But later when we will hook it up to a GitHub repository, there will be a status check over there. And we can basically approve this failed schema check here to make the check run pass. But for now, we saw, okay, there's an error, but we don't care. We will publish it anyway. So we'll still publish it. Yeah. And now we have our third schema version published. Okay, cool. So next, we can actually try to see how this would look like in a real Git repository. So I prepared this GitHub repository. So basically what is in there is, I actually can show it locally, that's smarter. So in there I prepared two workflows. So the first one is the CI workflow, and basically what it does is it runs schema check. And then we also have a CD workflow that runs schema publish. And then we just have like a simple schema file similar to the other one. But here, yeah, we don't have like a full server in there because it's not necessary for the demo. Just want to demonstrate like how the schema checks, the Git checks are mirrored to GitHub. So in order to do that, I will actually now quickly switch over to the hosted Hive, just because I don't want to waste the time now setting up a GitHub app and hooking everything up. but I assure you that everything that I'm now showing you is also possible with the local running GraphQL Hive. Just need to check out the documentation and figure out which environment variables to set. So I'm actually going to my private account here, gonna create a new project. Switch to the development target, again create a registry token. This time I will enter 2 characters, copy that, and now I will set the secret on my GitHub secrets on the repository. And the actions here. So this is the Hive token that we need to set. Post it in here, update it, cool. So, and now what we're gonna do is, so this is the schema. It's not yet published, so what I will quickly do is just create an empty commit, just to make sure the initial initial schema is published. I'm gonna push that. Never force push. Okay, cool. Yeah, so we have the initial commit, and now we can see that the check run is running here. And if we go into the details, ooh, Wi-Fi is dying right now. You can see that it's now running the schema publish workflow and it's failing. Why is it failing? Oh, yeah, I did not link yet the GitHub repository to the organization. This is the wrong one. So I will quickly go. If anyone is pulling Docker containers right now, please stop. Okay, I'll go to the organization, go into the settings, and then connect GitHub. And I will configure, and I will allow access to this one. Okay, it's already granted. And then I will to go back here. On the project, actually, we need to link the project to the GitHub repository. So that's what we're doing now. And now if I rerun this job, it should hopefully work. Let's pray. Oh, that was quick. It's not that actually. Schema publish succeeded. No changes, yes, because we already have the schema in here. Just the linking to GitHub failed, so the publish actually succeeded. So now if we go on here, you can see that the GraphQL Hive schema check was also transferred over to the commit. And now what we're gonna try to simulate is actually we create a new branch, like a pull request. And now we're gonna just change some things here, like change this field type, change this to a string also. Then we can add a new field user, and then we can just define that. Should be fine. We add this schema. Commit and push. And now we have our GitHub pull request. And when we create that, now our other workflow will run. So the CI workflow, this one. In the meanwhile, we can also check, like, this is our history of the schema that we already published. And now we're actually running the schema check. So any minute here should be like now a check for the pull request pop up. So here the schema check succeeded. The check run was created. So we refresh here. And now we see, okay, check run was run. And it actually failed. Why? Because we added some breaking changes. So we changed the field type. We changed another field type. And then also there is some save changes. Make this a bit bigger. So like adding the new user type and the new field on the query type is actually fine, but the breaking changes here were not so fine. So, but if we know now that, actually you can see that now the PR is also, the status check here is also failing. But now if we actually know that it's fine that we introduce these breaking changes, we can just, as a human being, approve it, and then override the failed schema check. So only do that if you know what you're doing. And then actually the PR status was updated to success. And because it's now successful, we can merge it, right? So let's merge that. And always delete the branch, very important. And then what happens if we now merge back into master, the deployment flow will run again, and that means that we will get a new schema version here. And the interesting thing is that when we publish a schema, it will not fail if there are breaking changes, because it might make sense to deploy breaking changes. The only thing that we want is to inform people that are working on a PR that there are breaking changes. In the end, humans still have to decide whether this breaking change is okay or it's not okay. So now we have our new version here published. This is our old version. And now we again have a list of the changes. We also have like a full div, and also it's associated with the commit on GitHub. So if anyone like wants to know why a breaking change was done, you can just look it up and then see who is to blame. Okay, cool. So that's the basic workflow for a single schema. Yeah, I created some screenshots just in case the internet dies. So, but not everyone has like a single schema, as we mentioned before. So many people have kind of like this supergraph, subgraph setup. And here what you can do is also use GraphQL Hive, obviously, but the flow will look a bit different. So each subgraph will probably have their own CI, and all of those CI systems will actually then publish to GraphQL Hive. But in that scenario, we need to use another project type on Hive for federated schemas. I will show that in a minute. And then also now we have another entity, which is the GraphQL gateway. In this example, we're going to use Apollo router. This will actually also then, after we publish the schemas, connect to GraphQL Hive for polling the supergraph that is then used for generating the query plan, where then the gateway can actually connect to the single subgraphs in our environment. Yes, so let's give a demo of that. So first of all, we need some subgraphs. Luckily, I already prepared those for you. I created 5. So we have a simple echo subgraph. I'm gonna probably show that one first. Let's start that subgraph, and then I will just execute some queries on it. Cool. So this is like the simplest subgraph. It just has like one field where we can send a message and it will return the message to us. Very simple. So the first thing that we want to do is publish this schema to a federation project within GraphQL Hive. And for that, we go to our organization. We create a new project. This time I will select Federation and I'll towards Hive Federation Workshop. Oh, wait, we actually want to do this locally, not on the cloud. So I'll do this here. Federation. So I'll again use the development target, and then we do the same. Again, we first need to generate a registry token for the access, copy that, and then we will update our file, our configuration file for the CLI. Oops. Save that, and then we can actually yes. So now we can use the Hive CLI. ppm run Hive schema publish, and we can actually reference the file directly because the Hive CLI can parse the schema SDL that is like defined within the TypeScript file. So we copy the path, schema publish, and now we also need to provide, because it's like multiple services in the federated schema, so we also need to provide a name. So in this is the echo service, and we also need to provide an URL. So this information is then later on used, so Supergraph can knows where what's the URL, or where is our subgraph, where do I need to send the requests. And this one is running on localhost port 7500. So I'm gonna publish this. Hey, and we published our initial schema. What we can now see here is in the history, we have a new version, and it also says that in this schema version, we published the echo service. Then if we look at the schema, we can also see like the schema of the service, but we have also more services. So we have like an account service, an inventory service, a product service, and a review service. And what I'm gonna do right now is just start them all in parallel. So this is pnpm start subgraphs, pnpm start subgraphs. So this is actually like starting all the subgraphs, and so you don't have to be me like typing out everything. I prepared the comments so I can just copy paste them. So we already published the echo service. Next one we will publish the accounts service schema to the registry. So now we have two services here. And then if we click on the history, you can see, obviously because I did not create another commit, it will use the same hash, but like in the real world it would then be different hashes because every schema published should be a different commit and also maybe a different repository. But here we can always see like which service was actually published within the schema publish. And then again we can have like a full div over the composite schema. This is actually already like the federated GraphQL schema. And then also for the single service, we can see a div. In this case, we just added the service, so there is no div actually. Okay, so next on, let's check actually if we can add the product service now to the existing schema or whether it would break. So instead of like doing a publish, we now do a check for the product service. And we detect 3 changes. First, enum value products was added for the join graph. This is like for Apollo Federation. Then a new type was added, and a new field was also added on the query type. And again, we can see all these changes in the schema checks on our GraphQL schema registry. So now that we know, okay, it's safe, then we can also publish this. And again, we now have a new version with all these changes that I mentioned before. Okay, so now that we know that the checks work, we can just publish all the remaining subgraphs. And now we should have a few more schema versions. And if we now look at the schema, it's quite a big schema now. And here we can also see all our individual services that were published to the GraphQL, to the Hive registry. So now that we have the schemas within our registry, the next step would be to actually spin up our Apollo router to actually get the supergraph from the Hive registry, and then basically open up a GraphQL server where you can query the composite GraphQL schema. Before we install Apollo router, quickly want to show how the CDN works. So we have a button here that says connect to CDN. We can push that, and then it will actually tell us where we can access the artifacts of this project. So in case of a federated project, we have access to the composite GraphQL SDL. Then we have access to the single services and the individual SDLs. And then we also have the Apollo Federation supergraph, which is actually what we are looking for now. So let's quickly copy that, store it here. Because what we also need is, when we access the supergraph, is an access token. And this is different from the registry access token. So we go, wow, I think this link is broken, Kamil. Anyways, let's go to the settings. Open the CDN access tokens, and then we just create a new one. We copy that one. And now, with these two informations, we can actually fetch the supergraph. I will just demonstrate this now with curl. So what we need to do is curl, then we set the URL, and then we also need to specify a header. I think it's uppercase. So the header name is Hive CDN key. We do that, and then we pass in the header. And if we execute that, we get found. What does this mean? Because we get redirected, so if we add the -l on curl, it will follow redirect, and that's how the registry works. We first do authentication, and if the authentication passes, you get a signed URL that is valid for a short period, and that will actually then bring you to the schema SDL. And here we have the supergraph that is ready to use. So, but for Apollo router, we don't need to download the supergraph URL, but what we will do instead is run router with the GraphQL Hive plugin. And the GraphQL Hive plugin basically can fetch the schema from the GraphQL Hive registry, and it will also poll it in intervals like the supergraph, which is needed for doing the orchestration. So I already prepared comment for running. So I already downloaded the Apollo router binary, because you never know about the internet. It's here. We can't look at it, it's a binary. And we can run it now. So what we need to run it is we need to pass it first the Hive CDN endpoint, which was the one I just used for fetching some data. And then we also need to pass the Hive CDN access key. So this is this one. I'll just replace them here. And then also we need to use this without the /supergraph. Pass this here. And now we should be able to spin up our Apollo router. Good morning. And it's running on port 4000, yes. So now if we go here, we can actually see oops. I think I'm not that well versed in Apollo Studio. Okay. We can select some data now on our composite schema. So we actually now have everything. We have, oh, I should make this bigger, right? So we still have our echo thing that I quickly showed. I don't want to do this. Just let me do this. So it works. So what is happening here? We have now an Apollo router that is actually forwarding the requests to the services that are running on our machine. And the supergraph is actually pulled from the GraphQL Hive registry that's also running on our machine. So now we can actually also query the other subgraphs that are there. Let's just use me, and then me has an ID, a name. What else do we have? We have some reviews that the person wrote. Oh, I'm really not used to Apollo Studio, sorry. Body, don't need the user ID here. And then every review has a product, and we also want to have the name, something like this, and also the shipping estimate. And if we execute that, we get all the data from all the subgraphs that we are querying right now. Yeah, and this is basically the setup that I just demonstrated. So the next level is usage reporting, because after we have like our GraphQL setup, we also want to know how is our GraphQL schema or our subgraphs used. And GraphQL Hive has like built-in usage reporting. So what you can do is either, yeah, so I will just show some screenshot for the moment. So you can like analyze the traffic that comes into your GraphQL API and then push this data into GraphQL Hive, and then you can get like information about which clients are used, which client versions are used, how many GraphQL operations are executed over time, what's the latency of the GraphQL operations, what are the single GraphQL operations that are executed. And if you're using like a JavaScript, Ruby, Java, or whatever server, we have like a Hive SDK that you can just put into the server. So I won't demonstrate this right now, but it's pretty simple. Like we just add like one line of code and it will be pushed there. Today I will only show like the Apollo router example. So the Hive Apollo router plugin also has like usage reporting built in. So every time you request is sent to Apollo router, we can forward the analytics data to Hive and then visualize it. So this is what we're gonna do next. I also prepared a comment for this. So we still have to like pass some additional environment variables for that. And we also have to like pass a configuration file. So here we have the supergraph.yaml file. Basically ignore this. What's important is these two lines. So we just say, okay, plugins, and we're enabling Hive usage. And then we have this comment. I will just quickly replace the environment variables here of everything. No, that's the wrong ones. These need to be replaced. And then the Hive endpoint is still the same. And for the Hive token, we actually need to use a registry token and not a CDN token. Like the CDN token is important because like if usage does not work, it's okay. But if we can't get the supergraph, we have a big problem because then no request can be made to our subgraphs. So if usage is not working, it's a problem, but it's not as big as if the requests just don't work. So what we're doing on Hive Cloud is actually the CDN is like different from the local Hive instance. So it's like on Cloudflare Workers. And for self-hosting, we still use the same logic, but instead of like running it on Cloudflare Workers, it's within the Docker container, within the API server. But in the future, we also want to make it possible for people that self-host to deploy the CDN part also to Cloudflare Workers or whatever we're working. We are trying to make it like platform agnostic. So anyway, so I need now to also fetch my registry access token, and actually I already created that, so I can just steal it from the Hive JSON file. And then I just need to pass it in here. And the Hive endpoint is where the usage data is reported. This is a different endpoint from the GraphQL API that is used in here, because the usage API is actually not a GraphQL endpoint, it's like Kafka, something like that. It's an HTTP server that writes to Kafka or something like that. Okay, so let's start this. It seems to work. Okay, so now we can actually look at the new tab that we did not look so far. So first of all, maybe the Explorer. So here we have a representation of our full GraphQL schema. So here we can see how often is a certain field used and by which clients is it actually used. So what I'm going to do is now again execute this query for a few times, and then hopefully after a few seconds, 10 seconds. 10 seconds? It's a long 10 seconds.
It's different time zone.
No usage data being reported. Let's try some more.
We can run it with debug.
Oh, it was a bit late. So back to Explorer, we can now see that this number increased. So what this means is basically that over the selected time period here, 7 days, this field was accessed 12 times. Jesus Christ. And then also we can see in the field usage that this field has been created 12 times, and all the requests that were sent to our GraphQL API actually use this field, like 100%. And then we can also see like here the operation that actually uses this field. I'm gonna click on there. Then we can see that I clicked 24 times, and all of them succeeded, and the average latency is 77 milliseconds. We did not specify a client name, that should be fine. And here we have like more details over when it was executed, request per minute over time, latency over time. And then finally we also have the operation here. And if we now also like, I don't know, let's just execute this without it, just to have some variation. We go to the operations. It's quite slow.
Oh, it's just because of the time frame. So if it's like before the end of the minute, just wait.
So we have to wait a whole minute.
No.
Yeah, so basically now we have like all this data in here, and we can now use this data for like making assumptions on how our GraphQL schema is used. And if we like also provide the client names, we can actually also see like which teams are using which GraphQL fields. And then if we're like deprecating a field, we can actually approach that team and tell them, hey, we're trying to deprecate that field, please move away from it. So even if it's like in some different team.
Where do you report the client?
I don't.
Yeah, so it's whenever you make a GraphQL request, you can specify, like, for example, if you have like a React app or like a mobile app.
Oh yeah, the question was like, where do we specify the header or like the client that is then showed here in the top clients. So if you don't specify client, it will show unknown. But as Kamil just said, like if you're using the JavaScript SDK, you can like specify how the header or like the client is like extracted, for example, from a header from the incoming request. And for the Apollo router, I think is it possible?
It's customizable. It's from the HTTP headers.
Yeah, there you can also like read it from the HTTP headers. So you would have to tell the clients that are requesting the GraphQL API, please use this header when you request the API. If not, you might break something accidentally. Yeah. So yeah, now we have like our two operations, and yeah, we can also see like, okay, this is 70% of the traffic, this is like 29% of the traffic, and yeah, all kinds of like useful statistics if you try to figure out why things are slow or might not be slow. So I want to show some more data here, so I'm going to switch to the cloud version for a small, real quick. So fun fact is actually that we're using GraphQL Hive on GraphQL Hive. So we have all like the information about GraphQL Hive within GraphQL Hive. So in production, we can actually see here also our operations. You can see the success rate, the failure rate. You can see like the different clients that we are using. So the Hive CLI is doing some requests. Unknown clients are doing some requests. The Hive app, which we are using right now, is doing some requests. And then also there's the Hive Ruby client that is also doing some requests, probably for like publishing schemas to the GraphQL schema registry. And then also we can add a version, so we exactly know which client version is like reporting something. And yeah, here you can also see like all the operations that are executed against the Hive GraphQL API. For example, token info is very popular because it's used by the CLI. And then schema publish is also very popular. And yeah, lots of interesting metrics that we can read from there. And this is basically how you use the usage data for pushing like statistics to GraphQL Hive. And another feature that is then built on top of that is conditional breaking changes. So conditional breaking change basically means that a potential breaking change is actually safe if the breaking change does not affect anyone. Like if we have a field in our GraphQL schema that is not used and we remove it, that's technically a breaking change, but if nobody is using that field, it's not actually a breaking change because it's safe based on the usage data that we have. And since we can like push the analytics data or like the usage data from our router or like from our server to GraphQL Hive, can based on that analyze whether in a breaking change or when we do a schema check, we can check the usage data on whether a field is actually used. And this can be done by switching over to local now. We can go to the settings tab on the target, and there we have a section conditional breaking changes. So we enable that. And then first of all, we can exclude some clients if we want to, but this is like the most important thing. So a schema change is considered as breaking if it affects more than X% of traffic in the past 30 days. So I can say if a field has not been queried or not been queried in the last 30 days, then it's safe to remove it from our GraphQL schema, and it does not require like manual approval by a human being. So we can enable that, and then that should work. Oh, must be less. Oh yeah, because why is it limited on the local version? We will fix that. Yeah, unfortunately it's like hard to demonstrate this because we now need to wait like for 7 days in order to do that, so I'll skip this for now. But yeah, this is how you enable breaking changes and based on the usage data. Yeah, there's also like other features that would probably take me 2 hours to set up because they're a pain in the ass, but we have built-in single sign-on support within GraphQL Hive, as I showed you before. So if you're like using Okta, Auth0 or something in your company, you can just connect it to Hive. Like if you're self-hosting it or if you're like using it on the cloud. I don't want to like make too much advertisement for ourselves here because Hive is like meant for everyone and it's open source. So, but I want to mention that even if you like use our cloud Hive version, which is exactly the same as the one you would be using if you're self-hosting it, there's like no tax for using SSO. Like it's a basic feature that is built in. Yes, as I said, all cloud features are available on self-hosted. Yeah, and that's basically the introduction to GraphQL Hive. And now if you have like any questions, feel free to ask them, or if not, we can like go into more stuff within Hive. Thank you. So a question there?
Yeah,
Do we have like a microphone for the audience so it's recorded? Or I can just repeat the question. Oh, there's a microphone. Can someone go on microphone duty?
Karaoke, everyone.
There.
I wanted this for myself.
So I was a little bit confused how the usage reporting works in Hive versus, I'm comparing it from my experience with Apollo and Apollo Federation. So you said the usage reporting all comes from the subgraph level, not the gateway level.
Actually, in this example that I just showed, it comes from the gateway level because Apollo router is like pushing the data to the Hive API. What I meant instead is that if you're not using Federation or something like that, you can just use the SDK within your GraphQL server for pushing the data to Hive.
Okay, thank you.
Another question?
Is it possible to bring your own dashboard and use the data that you have in Hive? If you have an existing dashboard that you want to use for user statistics or checks and publish.
I think Kamil can answer this one.
So there is one method.
Take the mic.
So the only method apparently right now is through a pull request, I would say. Yeah, but actually if you like self-host it, you can, everything that is available within the app, it has a GraphQL API. So if you self-host it, you can actually like extract data. And we have companies that are actually self-hosting and like enhancing the dashboard with their own statistics, even from like external sources, like Datadog or like their internal metrics and stuff like that.
Yeah, led to that. There's on the official YouTube channel of GraphQL. There's a talk by Albert Hein, and they did the exact same thing. They talk about how they ran Hive and added their own dashboards into it. Yeah.
There was another question over there and then here. Raise your hand, please. Okay.
Kind of a two-part question. The first thing, in the self-hosted approach, is my understanding correct in that when you hook up the GitHub repo to Hive, it's just for the purposes of sourcing the schemas to run the checks, not that Hive is using GitHub to store the published schemas?
Yeah, so GitHub is not used as a store, it's just like connect the GitHub repository with Hive for like sharing the information about whether it's a safe change or not.
So then I guess the follow-up question on that is, what does Hive use for storing the published schemas?
Okay.
And is that configurable to change it to something else?
It's not configurable, but how it's stored is we use many databases. So for everything app-related, that is like users, organizations, stuff like that, is stored in a PostgreSQL database. And then for all the analytics data, we use ClickHouse. And then for general like caching stuff, we use Redis. And then for the CDN, we actually use S3, but any like S3 compatible storage can be used as the CDN. The only thing that needs to be there is like some edge runtime that can access the S3 bucket. And this is still like a tricky part when you're self-hosting because it's not actually a CDN. It's just a fake CDN for now, but we're working on how we can even solve this for everyone. Because what we're doing right now is that we have runtime agnostic code based on the fetch API in JavaScript that runs on both Node.js and also Cloud for Workers. And for our cloud version, we deploy it to Cloud for Workers, and then it will communicate with the S3 API of Cloudflare. Don't know the name.
R2.
R2. And then for the self-hosted version, it's like embedded in the API, and it will talk to a Minio container. So actually, we give you like the Docker Compose file that is runnable by itself, but if you really want to run Hive in production, maybe you shouldn't run your SQL database in a Docker container. You should like maybe use a managed service, same for ClickHouse and Redis and also S3 or R2 or Minio.
Like the companies that like some of them are working that we work with, for example, one is the Bocom. They are using the Google Cloud Storage as a replacement for the S3. Yeah.
Question over there and over there.
Hey, my question is regarding the access tokens. So since there is only one access token, how do we control the access between different subgraphs? Like say subgraph A user can upload their schema on subgraph B. Like are there any preemptive solutions to tackle the access control?
We don't have like very fine granular access control yet. So, but it's on our roadmap because actually it's been requested by other people before. So it will come eventually. Over there.
Hi, thanks for the awesome presentation. So my question is about the versioning history on the Hive. So is the versions history on Hive linear? If so, how does it map to the the GitHub commits and branches?
Yeah, so right now the history is completely linear, right?
Yeah, it is. Yeah.
Yes. So what you would do is like connect Hive to like multiple GitHub repositories if you have like multiple subgraphs. And then, I mean, the order in which the publishers go through to the Hive API defines like the order. I hope that answers your question. Cool. Any more questions here and over there?
Are there any plans to support like...
Please talk into the microphone.
Are there any plans to support partial schema loading in like a serverless environment?
I'm not sure what you mean, to be honest.
Yeah, so if your schema is pretty large, like if you're in, larger than 1 megabyte type schema, you might want to be able to parse the query first and then load, a subset of the schema.
That's an interesting use case. I would love to talk about this more like afterwards, and then maybe this could become like a feature request that we could actually implement. Thank you.
Just add something to that. So we want to implement some kind of like filtering or like tagging, for example. So if you have like a huge schema that is like very specific for like, I don't know, reviews team or like because some people have like a giant API, but they have multiple products, and those products are not using all of the schema. So sometimes you just tag it with, let's say, I don't know, like a mobile schema or something like that, and then we can filter out all the bits that are used by those tags into like a partial schema, I would say. But yeah, it's a good thing actually.
Hey, thanks for the presentation. I was just curious, during the Hive publish part, we got to see the different aspects of like, hey, we added this field, we made this breaking change. Is there any patterns that you guys have seen where people have used that to generate like release documentation or schema documentation for external clients or users?
I don't think we have like seen anything specific based on that data, but since we store all this data like in a database in a structural way, like it's not just text, it's actually like JSON data. So every schema change is serialized. And actually the implementation for this comes from GraphQL Inspector. So GraphQL Inspector is used there. And we then serialize like the schema changes in the database. And I could see that you could use this data definitely for like generating change logs for your schema.
Yeah, one thing to add is that somebody has actually asked for such features, which is like they wanted to have a public page with the changelog of the schemas. Yeah, so we will try to actually add it. It's not like high priority for us right now, but if it is for you, then let's talk. Yeah.
Thank you for the great presentation. So I joined a little bit late, so I don't know if you already covered. Is the caching is possible in here? Like, how do you do that?
Caching?
Yeah, query caching, like say some
I mean, that's not scope of GraphQL Hive itself, I would say. Okay. I mean, I would rather see this like a scope of like Apollo router, right? So it would happen there, and it's like a separate thing in my opinion. Maybe Kamil has a different opinion, but I don't think it's something that is the responsibility of Hive.
When you ask about caching, do you mean like doing the caching itself on the supergraph, or do you mean? Okay, so yeah, so Hive is like the schema registry, and it works with any gateway. So it works with Apollo router, Apollo gateway, GraphQL mesh, any other GraphQL implementation, basically. So it depends on so you can hook anything into it, but it's not responsible directly to the caching part. Like you should probably cache on the gateway part. Maybe one interesting thing would be to use Hive's let's say Hive's data, like usage data, in order to configure your caching in a certain way. But that's just a random idea that I just have now. But yeah.
Yeah, and just to add something to it, when we say it's not in the scope of GraphQL Hive, what we really mean is that we don't control the gateway. So you can host it on Edge, you can host it like on Kubernetes, you can have it serverless, whatever. And there's no Hive in between. Like if there's an incoming GraphQL operation, it actually reaches the endpoint of your GraphQL API. It does the job. It never involves any like GraphQL stuff. It only pulls data from GraphQL and pushes to the GraphQL. There's no GraphQL like in between. You can use, for example, GraphQL Yoga with the caching plugin. That will work. You can use like GraphQL Mesh that supports Federation. That will also work. Yeah, and also like about like caching and stuff. The thing that could be actually useful in that area that is not really like in scope of Hive right now would be like even like persistent operations. We think about like maybe providing some kind of like management for the things that go in within the gateway that could be controlled centrally through some kind of like a tool like schema management or like gateway management, because then it makes sense because you have like a overview and you can control the gateways not through the code, let's say, or through the like configuration of the gateway, but like some external, so you can like apply rules and stuff. So yeah, it might be useful.
Yeah, just to add one thing that maybe you talked about before, but like when Hive is down, for whatever reason, theoretically, it shouldn't be ever, Yeah, but also all your systems will work. Like it has no effect on the requests coming in or coming out. Like it's a management tool. So requests coming into your gateway, then to your subgraphs. Hive is not in the pipeline at all.
With a question here and I think over there. No? Then over here.
Hey, good morning, everybody. I had a two-part question.
Yes.
It sounded like, from what you said earlier, that GraphQL Mesh also ties in and delivers metrics through Hive.
Yes.
And then my second question is regarding subscriptions. Do the metrics in Hive also reflect subscriptions as well, going in through the gateway?
Kamil, take the microphone and answer.
It depends on the implementation, for example. So right now, if you have like a SDK for JavaScript, it will work, I think, for Yoga, but not for the Apollo server right now. Yeah, so it's kind of, but it will work also for the Apollo router. So yeah, it should work.
The subscriptions piece?
Yeah, exactly.
Oh, okay.
The usage reporting for subscription, yeah.
Okay, cool. All right, that's good to know. And you said Yoga.
Yeah, for Yoga, yeah, because we have like we control the execution flow within Yoga. Whenever you request, GraphQL request is like executed. And Apollo server is actually different because they like extract the subscription part and it gives you, you control it. So that's some missing piece that we need to implement, but for Yoga it should work. Yeah.
Does Yoga include GraphQL Mesh?
Yes, it runs, yeah, under the hood.
No more questions. Okay, thank you everyone for attending this session.